My brother dropped off his little boombox, a little Sony audio system that was not working anymore. It was very intermittent, and the way he described it, it sounded like the buttons were just not registering presses, and these are tactile buttons. He also said it tended to cycle on and off itself. I have looked at the capacitors and the power supply, and I'll have to order some because it's not a size I have, but the cycle on and off may actually be down to these failure of these switches, because if I zoom down these are classic tactile switches. They have a little dome inside that when you press it down, it makes that characteristic clicking noise. That's the tactile bit. And they're very, very prone to failure in two ways. They can form internal conductive bridges inside that mean that a button may almost seem like someone's just repeatedly randomly pressing it because it's grown little whiskers across between the two connectors. But the other common failure of this, and I think this is both these issues, is that particularly where there's surface corrosion on these ones is internal corrosion of the little tactile disc. And when you press it down, initially when it starts playing up, you may have to just jiggle the button and try and get it going. But later on, you'll find that no matter how hard you press it, it just doesn't respond. And the answer is, well, the cheapest answer for ruling things out is to change all these switches. So I'm going to do that. I have dug through my collection of switches and got some replacements. So the first thing that I'm going to do is focus down onto here. I'm going to make sure this is focusing. Does it focus up there? Does it focus down there? It focuses. This is good. Give it things to focus on. The first thing I'm going to do, though, is reflow all the solder joints. And the reason for that is because it's going to make it easier to remove these, because the solder that's on them may be lead-free and very crusty and dry, as lead-free tends to be. I know lead-free has its lovers, but I don't love lead-free. And what this does is by applying new solder onto all these switch contacts, when it comes to desoldering them, it's going to be easier to melt the solder each time we do it. This is a single-sided circuit board. That's very good, because double-sided circuit boards are a nightmare for desoldering small things from. If it comes to it, you can get a fine pair of snips and you can basically go in and cut the pins and then just desolder and drag them out from the other side to avoid damaging the circuit board. But anyway, I shall pause while I reflow the solder on all these connections. Okay, now I've wetted the solder. I'm trying different approaches to this. I could use a desoldering pump, the electrically assisted one. I do have one, but it takes ages to dig out and then heat up. So I'm going to try the tap approach, where you basically, you melt the solder and then you tap it and hopefully it all flies off. Doesn't always work. It depends on the system, but it will get quite a lot of the solder off. Just make sure you don't break the circuit board. The other option I have here is to use my favourite method, which involves desoldering wick, which I've misplaced. One moment, please. I've found my desoldering wick. Now, I find it better to get the best results from desoldering wick, get some flux, liquid flux, and just drizzle it onto the solder wick so it's got a little bit of extra flux in it, because it does tend to come with flux, but that dries out. So I'm just going to drizzle a bit on here. And then I shall apply it to these solder pads here. And hopefully it will just suck all the solder up and leave super clean pads. The problem with the switches is that because they've got spring-loaded pins that splay out as you put them through, sometimes you can't really get all the solder off. It just creates a very slight meniscus at one side. But let's try this. If in doubt, well, we could do that actually. Cut the pins on the switches, because that can free the thing up. You only really need to cut on one side, because as long as you can hinge it up, you can grab it, and then by alternating between the two pads, you can then get the other side free, which it is now. The switch is out. So I think I'll go with that approach, and then removing the sort of pins. Quite often they'll just drop out of them their own accord, which they have done. Okay, I shall continue and desolder all the switches like this. One moment, please. So now all the switches are out and the holes are clear. We get the replacement switches, and these ones are quite interesting because if sized correctly, they clip in. They actually have little bends in the pins that hold them in position, which is very good. Takes a bit of experimentation. If you're designing your own circuit board, you can look up the specifications for the holes that they recommend a specific size, and you can try different experimental diameters if you make your own prototype circuit boards to find the ones that are the easiest to put the switches in. If the holes are just a bit too small, they will take the leads, but they won't click in as easily. So this is probably the easiest bit of the whole project. Clicking these switches in before soldering them. And they do tend to hold themselves quite flat, but I do recommend soldering one lead of each switch and then checking that they all have properly laid flat, because if they haven't, you can reheat that one solder joint and then press it gently while you're reheating it. So I'm just going to flow one of these. I'll just flow a few at this end. No, I'll flow them all because I've started, so I'm going to finish. It doesn't take that long. Putting the switches in is easy compared to removing them. There's quite a few of these buttons. They are a really common button. It's nice that the industry actually standardizes in some things like this. So how are these? These are looking very level. So I can go ahead and solder all the other ones. I won't bore you with that. I'll just jump to the end. And that's it. I have replaced all these switches. There is a little bit of residual flux inside, but I'm not going to wash that off because there's always the worry that you're going to actually get some flux into the switches, and that doesn't help at all if it's in the contacts. But that's it. Now I'm going to put it into the equipment and see if it fixes all the problems. Okay, now here's the horrible bit where I try and get the horrible little ribbon cable into this housing, and I've had to remove a bit of the support chassis in here to even get access to it. These ribbon cables are horrible because they're only really designed for X number of insertions, and then they start getting all floppy like that, and there's a very good chance that at some point this is going to break. I wonder if it'd be better actually pulling it out of that side. There's no obvious easy release in this. It just appears to be a very friction. No, there's no obvious release. It's horrible. This is a bit that will potentially destroy the product because I don't know if I'll be able to get another ribbon cable for this. Hopefully I've not damaged that. Let's try and put that back down there now. Where's the contacts? Yeah, I think it's that way. We'll find out when we actually power it up. If it even responds to the buttons now. If it doesn't respond to the buttons, that's bad news. So now I'm going to sit this down into this area here. The buttons sound a lot better already once they're all pressed down into position. Horrible button actuation system though. Very little clearance. Actually, that doesn't sound great. This isn't sitting down properly yet, that's why. Oh, there's so little clearance in here. This is why when someone brings audiovisual equipment to you, you should politely say, no, I'm sorry, I don't repair audiovisual equipment. Rightio, let me get the frame into this and we'll put it back together and see if it works. Okay, let's give it a go. So I'll stuff a CD in the top. It is a CD player. In it goes. And it says loading in very dim display here. And we'll just bump through to, I'll wait for it to finish loading. And we'll bump through to a suitable track. And start it playing. And that looks absolutely fine. All the buttons are working, but I have to confess here that the tolerance between those switches was so fine, because this Sony unit may actually use a custom switch, that the size of that tiny little plunger on top was so critical that I had to literally put on some of them, because you could see a visible size difference from the same pack. I had to put a drip of ultraviolet curing glue and then get the ultraviolet light into it to actually pack the switch up a bit. But now that's done, it seems to be fine. I will say I'm not convinced about the reliability of the CD eject mechanism. It seems to be working at the moment, but I think it's wearing out. Maybe time for Ralph to get another device. But there we go. That is a successful fix of this device. Incidentally, if you ever have to take one of these apart, it's a, what model is this? It's a Sony CMT-X3CD. To take it out, you've got 2 deep screws here, and you've also got 4 screws in the bottom here, and then after that you're going to have to get the spudger in and get the grid. The grill in the front has to be unspudged and at the side and then hinged up, because it's got little sort of insert hinge pins here, and that's how to gain access to it. And for the CD mechanism itself, it's these little silver screws. For further access, then you have to take down the sub chassis of those screws down there. It's a bit finicky, like most of these things. This is why I don't generally repair domestic items. They're not really designed for repair. They're just mass-produced and disposable items. But there we go. This one is not disposable. This one is now fixed.